So first off, I'm going to pass it over to Amir to kick things off by sharing more about enabling field biomechanics through multimodal sensor function. Very cool. So Amir, whenever you're ready to take it away, floor is yours.
Hi everyone. Thanks for coming to my quick talk. I'll do my best to distill everything that we are working on or have been working on for the last, I guess, over 10 years. Today I'm going to be talking about how we can do, or how we've been trying to do biomechanics outside of a lab environment. And I always start because, showing off this incredible animal called the cheetah, which I'm actually from South Africa and been studying him for most of my life, trying to understand, how they are able to be so maneuverable and how, they're able to pull off these incredible feats of agility. Because I really was interested at the start, I guess, to build the next generation of robotic systems. But in doing so, I discovered that there wasn't actually much known about cheetah biomechanics, particularly from like a whole body perspective. So in my lab, we study this animal along multiple fronts. So we develop multi-body simulations, we employ feedback control and optimization techniques, and then we also build robots to understand, functional morphology and so on. But today what I'm going to be talking about, which is I guess the most difficult part of this work, is actually trying to understand and measure what the animal is actually doing out in the wild, which is we use lots of techniques in computer vision and state estimation. So I started my journey trying to, get some data on how these animals move. And the first thing was, okay, we should just put collars on them. But the problem with these GPS and IMU collars, many of you know, is that you get this animal with all of this articulation in its, legs and spine and tail and even its head. And it essentially reduces it just to, this like flying axis. So you've lost all of the information about, how it's able to perform these various maneuvers. So like, what kind of limb coordination did it require? What kind of flicks of the tail? So, GPS collars aren't going to work for these needs. So the first thing I did was I thought, okay, what if we put more sensors on the animal? So we developed this harness system, which we tried on some captive bred cheetahs in South Africa. And we developed a sensor fusion framework. And the cool thing is that we were then able to reconstruct the spine and tail motion without any external cameras on the cheetah. So you can see at the bottom there. So how it works is we have some backwards facing cameras on the harness, which are looking at the spine and the tail. And we also have an IMU and GPS system on there. So this is what it looks like. This is some footage if you ever want to know what it's like to ride on the back of a cheetah. So this is not sped up or anything. So yeah, we were able to do this full reconstruction, but unfortunately, many of the cheetahs found it a bit cumbersome to have this harness. So what we thought of is we need to do a fully remote non-contact system. So luckily, we partnered with GoPro, and they gave us a ton of cameras, which we then placed in cheetah sanctuaries in South Africa. We then collected lots of data, and like I think 3 years worth of video footage. However, many of the cheetahs we weren't allowed to put any, reflective markers on. So I managed to meet these really smart people, Mackenzie and Alexander Mathis, who are now at EPFL, developed DeepLab and we extended DeepLab to work outside in 3D environments. So I don't know if some of you may have heard of DeepLab, but how it works is we take a video and then the neural network can label the 2D key points, so the skeleton in the frame. So what we did in this example was we take all 6 views, which DeepLab the same network labels, and then we fuse that to create this, I guess, like full 3D skeletal reconstruction, but outdoors. So I was really excited when I saw this because you can see that's clearly the motion of the cheetah. The red dot is the lure that it's chasing during enrichment. So really, really cool, cool stuff. So the other part we had one problem we had was that the cheetahs we were working with didn't have the same motivations as the wild ones. So I approached GoPro to develop a long-range motion capture system called WILDPose. And the idea here was that we were going to use long-range LiDAR, actually used in autonomous or self-driving cars, and fuse that with a telephoto high-speed video camera. And got some really cool results. So we went to Kalahari National Park in South Africa on a couple of field trips. So we got some really cool video footage, obviously, cool stuff with lions and springbok over there. But the cool part is now we also have this 3D LiDAR point cloud data. So you can see that's our giraffe at the top there, but we also now have time synchronized, calibrated 3D points. So we can do really, really cool things. Some examples like we can study, group dynamics. So by viewing a herd from the side, we can track how individuals are interacting with one another. So you can see the, individual 6 and 7 or, fighting, and then they go off. And so really, really cool applications. Another one, which we sort of stumbled on, we had this lion sleeping on the side of the road. It was about 60 meters away. And we could then actually track its breathing by measuring the displacement on its chest. So quite interesting kind of application I didn't expect. And then obviously my real passion is we could then study things like hunting. So this is a cheetah mother taking down a springbok with its cubs. So on the left you see the video, but on the right we also have the 3D points, which we can now fuse to get 3D whole body kinematics outdoors from really far away. So yes, that was my quick talk. I know I went through really quickly, but I just wanted to make sure that I covered everything so there was enough time for questions. If you are interested in any of my work, please check out my email, and thanks to my sponsors and funders for generously supporting this work. Yeah, thank you.
Thank you so much. Really, really cool. Very interesting. The whole POV in the back of a cheetah is awesome. My question for you is if someone, what do you want people to come and like talk to you about? Like, are there any like future collaborations that you're looking to sort of like investigate, or like what makes you super excited that you would want to talk to someone about for hours on end?
Yeah. So thanks. Yeah. So I'm actually an engineer. So like I said, I my journey was I came from this as a robotics person trying to build faster robots, and I kind of stumbled into this world. So I'd be really interested to see, are these technologies like useful? Because I'm often a bit worried that the kind of things that we're developing are cool tech innovations, but maybe they're not like really useful for people. So like I think I'd love to hear if anybody's actually interested in these kinds of things for the application. I mean, obviously it doesn't have to be cheetahs, it could be anything, to see how like multi-sensor fusion could be useful for them.
Amazing. Well, thank you so much for that talk.